Okay, how do we calculate a relative atomic mass for a mass spectrum? Well, we use the same equation that we used for calculating relative atomic mass, but we just need to interpret a mass spectrum. So here's an example of a mass spectrum of an element here. What information can we get from it? Well, the bottom axis on a mass spectrum is the mass to charge ratio. In terms of a mass spectrum, the charge will always be +1. So the mass over +1 equals the mass of the isotope. So these here are the masses of the isotopes that are present, and we can see that we've got 3 different isotopes there. Up the side is the relative abundance, so we just need to read those off the graph. So looking at this one, that's 79%. This one's 10%, and this one is 11%. So we then just use these figures. So 79% is the abundance, 24 is the mass, and we put those into the equation. What you could do now is you could pause this if you wanted and have a go at that to see if you get the same answer as me. If not, you can just keep going. So my calculation came out. Just put that over there so you can see. Just going to clear those off. Let's get rid of that. So therefore, there's our calculation there. So 24 times by 79, 25 times by 10, and 26 times by 11. Put those in using the brackets correctly, and you'll end up with 24.32. Actually, I've made a mistake there. That should be 2, 4. And then you can actually go to the periodic table and work out what element this must be. And this is what they do on space probes. So let's really bring that to the front. The 24.3 is a mass number. Hopefully you can see is magnesium. So therefore we've identified magnesium.